Hello guys, welcome again to this session. In the previous session, I explained vector equation of a line, and I was able to solve a few examples. Now in this session, I'll teach you guys the intersection of two lines. Okay. So if I have two lines, let's take for example these two lines. Okay, these two lines are parallel. Don't mind my drawing. These two lines are intersecting. Why these lines, let me draw this way, are skewed. So these are two parallel lines. Okay, these are two intersecting lines, and these are skewed lines. So for this, these two lines are parallel, like I said. So these are what we mean by intersection of two lines. So if you take a look at this line is intersecting at a point. Okay, so our aim is now to find the position vector of this point where the two lines intersect. So for example, if I have the x and y axis drawn, so on this graph, we have a point which is the intersection of these two lines, right? So if I want to find the vector equation of that point, then that will be, let's say this is R, then this is OR, okay? So I need to find OR to know the vector equation of this line OR. So let's take an example. An example is find the position vector of the point where the following lines intersect. So this is the vector equation of a line. This is the vector equation of another line. Remember that I said that a vector equation of a line R is equal to 1 minus lambda A plus lambda B, okay? R is equal to A plus lambda B minus A, okay? In any of these two forms. So I hope you are not confused that why do we now have this other letter here, mu? Because these are two different lines. So we try to use two different symbol or notification for the two lines. So lambda for the first line, then mu for the second line. I hope this is understood. So since the question says you should find the position vector of the point where the lines intersect, that means the line intersects. Do you understand? So if you have two lines and they are intersecting at that point, that means the position vector of the intersection of both lines is the same. So if this is line AB, for example, the position vector is R, which is this. If this is line CD, the position vector is also R. That means for both lines, the position vector is the same for both lines since they are intersecting. I hope you understand that. So this implies that this line and this line will be equal since there is a point of intersection. So that means I can write this as 2, 3 plus lambda 1, 2, okay, will be equal to 6, 1 plus mu 1 minus 3, okay? So if you take a look at this, all this is the x-axis and this is what is the y-axis. Then we compute this together using simultaneous equation to find lambda and mu. So let's do this. So this becomes 2 plus lambda, because lambda times 1 is lambda, is equal to 6 plus mu times 1 is mu, okay? Then 3 plus 2 lambda, because lambda times 2 is 2 lambda, is equal to 1. Then minus 3 times mu is minus 3 mu. I hope this is understood. So to do this, there are several methods to solve simultaneous equation. You can use the substitution method. You can use the elimination method. But before we do that, let's try and collect the like terms for both equations. So for equation 1, we have this as lambda is equal to 6 plus mu minus 2. I hope this is understood. Because these two comes with the other side to become negative. So lambda is equal to 4 plus mu, because 6 minus 2 is 4. So this is equation 1, this is equation 2, then this will be equation 3. Okay, then I can substitute the value of lambda into equation 2, because equation 3 is gotten from equation 1. So I should not substitute equation 3 into equation 1. I should substitute it into equation 2. So this implies that this is 3 plus 2 lambda. Then what is lambda? 4 plus mu, okay, is equal to 1 minus 3 mu. So with this we can find mu. Is that understood? So this becomes 3 plus, then this becomes 8 plus 2 mu is equal to 1 minus 3 mu, okay? So 3 plus 8 is 11 plus 2 mu is equal to 1 minus 3 mu. So that implies that 2 mu plus 3 mu is equal to 1 minus 11. So this is 5 mu is equal to minus 10. So mu is equal to minus 10 divided by 5. That means the value of mu is equal to 2. I hope this is well understood. Oh, sorry, is equal to minus 2, not 2, because minus 10 divided by 5 is minus 2. So now we can now substitute the value of, so we don't have to find the other value, which is lambda. So we just take any of the two values. Since we found mu, we have to take this value. If it was lambda that was found, then we take this equation, okay? Since both equations are equal, you don't have to substitute both. Just find one of them. I hope you understand. So since we found mu, so that means the position vector will be equal to 6, 1 plus mu 1 minus 3. If we have found lambda, we will have taken this equation, okay? Okay, good. So that means R is equal to 6, 1. Don't forget that mu is minus 2, okay? Mu is minus 2, 1 minus 3. So R is equal to 6, 1, okay? Then minus 2 times 1 is minus 2, isn't it? Minus 2 times minus 3 is plus 6. Is that understood? So let me write plus here. Then this becomes minus, okay? Because minus 2 times 1 is minus 2. Minus 2 times minus 3 is plus 6. So that implies that the position vector is equal to 6 minus 2 is 4, and 1 plus 6 is 7. So this is the position vector of the point of intersection between these two lines. I hope this is well understood. Now the next example. Find the coordinates of the point of intersection of the lines A to B and C to D. Very easy. So the first thing to find is line AB, the vector equation of the line AB. Since we have the vector A and vector position B, then we can find AB. How this is understood? So to find AB, so we know that line AB will be equal to OB minus OA. Okay, OB minus OA. And OB is equal to 4, 0 minus OA is 1, 6. So that means AB is 4 minus 1, 3 minus 6. So this is AB. Okay, and the vector equation of a point on line AB will be equal to OA, okay, OA plus lambda AB, isn't it? So that means the vector equation of a point on the line AB will be equal to OA, and OA is 1, 6 plus lambda AB, and AB is 3 minus 6. So this is the vector equation of a point on line AB. How this understood? So the next thing is to find CD, because the question says A to B, then C to D. That means CD. CD will be equal to OD minus OC, as explained in the previous session. Okay, so that implies that CD will be equal to OD is 5, 3 minus OC is 1, 1. So that implies that this is 5 minus 1, 4, 3 minus 1, 2. So this is CD. So the vector equation of a point, okay, this is R1. Vector equation of a point on a line, on line CD, will be equal to OC plus mu CD. I can also write lambda just for the difference between the two lines. So R2 will be equal to what is OC? That is 1, 1 plus mu. CD is what? Is 4, 2. So I have been able to get the vector equation of the point on these two lines. So since this line intersects, we are asked to find the coordinate of the point of intersection. Since this line intersects, that implies that R1 must be equal to R2. Then R1 is 1, 6, okay, plus lambda 3 minus 6. It must be equal to R2, which is 1, 1 plus mu 4, 2. I hope this is well understood. So doing this will result to 1 plus 3 becomes 1 plus 3 lambda. 6 minus 6 lambda is equal to 1 plus 4 mu, and this must be 1 plus 2 mu. So you have to solve this simultaneous equation using any of the method I mentioned earlier. Okay, so solving this will result to the lambda equals 2 divided by 3. So like I said, you can either find lambda or mu. Anyone you find is fine. So since lambda is equal to mu over 3, that means I have to take this equation, isn't it? Since I did not find mu. If I had found mu, I would have taken this equation. Okay, so now, so the vector equation, the coordinate of that point, okay, the coordinate of that point will be equal to, it will be equal to 1, 6 plus lambda 3 minus 3 minus 6. Okay, 3 minus 6, which is equal to lambda is 2 over 3. That will be 1, 6 plus 2 over 3. Then what? 2 over 3. Then 3 minus 6. So like I told you earlier, you have to evaluate the bracket first, right? This lambda first. So this is equal to 1, 6, then plus 2 over 3 times 3. 2 over 3 times 3, that becomes 2. Then 2 over 3 times minus 6. 2 over 3 times minus 6. This is 2, that is minus 4. Okay, that becomes 2 minus 4. Now, since 2 minus 4 is gotten, that means the vector equation of that point of intersection will be equal to 1 plus 2 is 3. 6 minus 4 is 2. So 3, 2 is the vector equation of that point on these two, of the point of intersection of these two lines. Is this understood? I hope this is well understood. If you have any question, you can write in the comment section. Thank you. See you in the next session.